Here we go, ladies and gentlemen. We are back to the Wednesday live stream where we're doing Khan Academy SAT problems. We're working on Khan Academy SAT practice test number 4. And I'm very excited about that because that means we're almost halfway done here through all of the Khan Academy SATs that are given on that website for the math sections anyways. So all I'm doing right now is I'm just making sure that my live stream is indeed going. Hopefully you can see me out there. So I just like to test because every now and then we have some mishaps. So I'm going to take a look here on my channel on my phone. Whoops. Let's take a look here. Yep. All right. We are up and running. So it looks like the live stream is going. Let me just click on that and see if it's actually picking up as I'm talking. And yeah, boom, 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 boom. Beautiful. Okay. So let's turn this guy off. We don't need to be hearing the double sound. So as you can see, I've got my setup all good to go. We're going to move this guy away. Let's minimize this. Now, if this is your first time watching me do a live stream, you can see here I got Khan Academy open, already in practice test 4. I did this section last week, so now we're going to start the math calculator section. I got my calculator open up here so I can switch back and forth so you can see all the calculations I'm making. And this is under time conditions, 55 minutes, and we're going to use that time, take it under time conditions. And again, I'm seeing these problems for the first time, so that's always part of the fun. I'm here solving these problems with you, which makes it all the more interesting. Ready, set. 38 questions, 55 minutes, and let me move this. Let's move this. Begin. Continue first question. The monthly membership fee for an online television and movie service is $9.80. The cost of viewing television shows online is included in the membership fee. There's additional $150 to rent each movie. For 1 month, Jill's membership and movie was $12.80, so it's $9.80. And then obviously that $12.80, we could minus that, right? And we see that we get $3. So that means how many movies did she rent? Well, the cost of the movie is $3, $1.50 for each. So that is 2 movies. Next. We've got here, sorry, let me erase this. One of the requirements for becoming a court reporter is the ability to type 225 words per minute. Donald can type 180 and believes with practice he can increase his typing speed by 5 words per month. Okay, which of the following number of words per minute that Donald believes he will be able to type M months from now? So basically every month we're hitting 5. So we're starting at 180. So 180 should be the base plus 5M, right? It's increasing. If we're at month 1, we're at 185. Month 2, 190. That's why C is the correct answer. Let's go on to question 3. 3-pound pizza is sliced in half, and each of the 3-pound pizza is sliced in half, and each half is sliced into thirds, right? Oh, whoops, that's wrong. It's like this. There's the thirds, 1, 2, 3, and then this one is 1, 2, 3. What is the weight in ounces of each of the slice of pizza? So it's 1/6. Okay, so 3 times 16 gives us 48 ounces, and then it's divided by 6. So each of these are going to be 8 ounces, right? Okay. Question 4. Nick surveyed a random sample of freshman class of high school to determine whether the festival should be held in October or November. Of the 90 students surveyed, 25.6 prefer October. Based on this information, how many students in the entire 225-person class would be expected to prefer fall festival in October? So that means it is 74.4%. And then it's 74.4 of 225, right? Oh, no, sorry. They want October. So it's 25.6% times 225. So let's get the calculator. 0.256, converting it to a decimal, times 225 equals 57.6. So I'm going to go with about 60 because it says about how many. And so we said 9 students. Let's make sure we understand. Prefer October. Would expect having it in October. And so I believe it is 60. Okay, we can revisit that one. I did a little fast. The density of an object is equal to mass divided by volume, right? That's what it's saying. What is the volume in millimeters of an object with the mass of 24 grams and a density, so we want volume, and a density of 3. This is just solving for V. So what would make this true if V is 8? Okay, because 24 divided by 8 gives you 3, right? So I kind of did that one a little fast. I have to go fast during these early ones because they start to get much harder, and then the multi-step problems, we need to make sure we have a nice buffer of time. So it says last week Raul worked 11 more hours than Angelica. If they worked a combined total of 59 hours, okay, so R equals A plus 11, and then they work a total R plus A equals 59, system of equations. How many hours did Angelica work last week? So we want to know what A is. I'm going to plug in A plus 11 in for R, right? The little substitution. A plus 11 plus A equals 59. That's 2A plus 11 equals 59. Subtract 11 from both sides. I'm writing like diagonal. I don't know why. 2A equals 48. A equals 24. Okay, you see? So we've got A right there, and we're not even going to worry about it. We know that is sound. We could check that again if we had more time, but I'm not going to worry about it now. Let me try and write straight this time. The table to the left represents the 50 movies that had the greatest ticket sales in 2012, categorized by movie type and motion picture. 50 greatest in 2012. What proportion of the movies are comedies with the PG-13 rating? So comedies with PG-13 rating are 4. And we want to know what proportion. So it's 4 out of a total of 50, right? Which reduces to 2 out of 25. And that would be this guy. And we can double check this, right? I'm pretty sure I read everything correctly. It's very straightforward. What's the percentage of those, that one category? And I think that's good. Okay. So let's go on to this one. It says line L in the XY plane contains points from quadrant 1, 2, 3, and 4, but not in 1. So if we drew this out, it'd be a line like this or something. Oops, not like that. It goes right through the origin. It'd be a line like this. So here's quadrant 1, okay? Which of the following must be true? The slope of the line is probably negative, because there's no way it can be positive and not go in there, right? Even if we're doing it over here, anywhere it's going to eventually cross over there. So it's definitely not positive. It's definitely not 0, because 0 would be like, I mean, it could be 0, but then it could be down here, but then we'd miss quadrant 2, excuse me. And undefined, no, that undefined is going straight up and down, so it's a negative slope. And see, I didn't know that. I had to draw it out. So I encourage you to do the same for a problem like that. The table above shows the number of registered voters in 2012 in thousands in 4 geographic regions and 5 age groups. Based on the table, if a registered voter who's 18 to 44 in 2012 is chosen at random, which of the following is closest to the probability the registered voter was from the Midwest? Okay. So we've got 18 to, 44. So it's this group here. And we're choosing somebody out of this range, right? So our total for this range is those two combined. So 14, 7, 6, 6 plus 47, 8, 9, 6. So we got to add these. I'm just going to do it here and not use a calculator because I think it'll be faster. 15, 16, 11, 12, 1, 6. So it's 6, 2. So we want to know what is the probability they're from the Midwest. So it's 6, 2, 6, 6, 2. And then over that is these two guys added together. So I'm going to do a rough estimate, okay, because we just don't have time. So 3,500 plus about 11,000. So 14,000, let's say 14,600 about. Say 14,600, and I'll use a calculator. 14,600 divided by, I think, 62,000? 62,662 or something like that. It's approximate. It's about a 0.23. And I estimated there, so I think 0.25 is going to be our answer. It's about a quarter. All right, next. What is the life expectancy in years of the animal that has the longest gestation period? So this guy has the longest gestation period, right? We're looking at gestation period here. We don't even need to really read this, I think. And the life expectancy is 3 years. What is the life expectancy of years? Yeah, so I think we're good there. We don't have to worry too much about this problem. Hey, there's another question. Of the label points, which represents the animal for which the ratio of life expectancy to gestation is greatest? Basically, this has got to be really high relative to this guy. So this is like 10 over 28. Oh, no, the number of the letter, it's A. It's A, right? Because these guys are around the same life expectancy, but it has a ratio of life expectancy to gestation. So life expectancy over gestation, this would be like 8 over 42, 8 over 50, whatever, 10 over 50. But this one is like 7 over a much smaller denominator of 22, right? That's almost like a third. This is like a fifth or something like that. So I'm going to go with A, and we're going to go to the next question. In the xy plane, let's go back to this. The graph of function f has intercepts at -3, -1, and 1. What that means is we got -3 here, -1, and 1. So it's going to go something like that. It's going to look something like this. I'm just totally guessing. Which of the following could define f? Oh, so these are the x-intercepts. So that means it's got to be x plus 3, right? X minus -3 times x plus 1, x minus -1 times x minus 1. This is how you basically put in all the roots, okay? So x plus, nope. X minus, nope. X plus 3, x minus 1, x plus 1. It's C. All right. That may not have been the clearest explanation, but like I said, I got to be mindful of time. Which of the following best describes the relationship between time and the estimated population of mosquitoes during the 20 weeks? Time and mosquitoes during the 20 weeks. So it goes like this. This is going up progressively. So 5, 10, 15, 20 by 5 every time. It's going up by 100, then 1,000, then 10,000. Then 100,000. So if you want to think that's linear, okay, it's definitely positive. It's definitely increasing. So it's not, not B. I'm not going to say this is linear. This is actually exponential growth. If you want to think about it, it's like, look, here would be, let's say this whole thing goes up to, let's just say up to 10,000. All right. So 100 is like way down here. So first we'd be like 5 and we'd be way down here. Then it'd be like 10 and then we're way up here, and then remember an equal distance here at 15 will be 10 times higher than that. So you can see it's a curve going up. It's not a straight line that has a consistent slope. It's definitely exponential. Next, the expression above gives the amount of money in dollars generated in a year by $1,000 deposit in a bank. This is, by the way, this is compound interest. Yeah, this looks like the formula for compound interest. And okay, so anyways, pays an annual interest rate of R% compounded monthly. Yep. Which of the following expressions shows how much additional money is generated at an interest rate of 5% than 3%? Okay, so the interest rate goes right here, but they're also not including something here. The amount we're compounding. Oh, actually no, it's just n times t, so that's going to stay consistent. So what it would be is we'd plug this whole equation in. First we plug it in with 5 for r, and then we plug it in with 3 for r. So the question is it straight up this guy? Okay, this kind of makes sense. It's like a subtraction, right? So it's like we're hitting that extra 2% over and over. Let me just think of this is actually it. Okay, this almost seems right, but this is they're straight up calculating it at 5% for the same amount of time, then at 3% for the same amount of time, and then taking the difference. So this is our best bet right here. We don't even need to do the calculation. All right, next let's go with this guy. Which of the following scatter plots shows a relationship that is appropriately modeled with the equation y equals a? It's an exponential equation where a is positive and b is negative. Oh, they threw a curveball. So y ax to the, let's say, -2 or something. Okay, so what's happening as this gets bigger and bigger and bigger? This is, again, remember, this is the same as if it's a negative, it's really a over x to the squared or something, right? So what happens is as x gets bigger, this denominator gets closer, it gets larger, and this whole number gets closer and closer to 0, because it'll be like 1 over 10 maybe, 1 over 100, right? You see that getting smaller. Staying positive always, but getting smaller. So what means is it's going to kind of go like this. As x gets larger, it's going to get closer and closer to 0. So I'm going to say that B looks pretty good. That looks like exactly what I drew. So I'm going to go with that. For what number of days X will be the total cost of buying the materials and renting the tools from store B be less than or equal to the total cost of buying the materials and renting the tools? Okay, so for what number of days will the total cost of buying the materials and renting from B be less than or equal to the total cost of buying the materials and renting the tools from store A? So let's look. So what are we doing? So we're talking about, is this B and A only? Yeah. So B and A, and God, it's a lot of text here. I got to reread this. We're looking for B will be less than A. B is less than A. How many days? So the fixed cost, I'm assuming, of A is higher. Yeah, A is higher. So first we got 750 plus 80. Let's just say rental cost wheelbarrows per day. Let's just say 80x, 80 whatever. We've got those two values. And well, what is x? Oh, x is the number of days and dollars per day. Dollars. So let's just say 80x. We want to know when this will be, and we actually want to know where. Sorry, we want to know where. We want to know where B. Yeah, no, I had it right. This will be less than 750, and then this will be 600 plus 25, 105x. So it's like you can see it starts off at 0 days. This is cheaper, clearly, right? And then it's a differential of 25. So this is gaining by 25. So it's 6 times 25 will get us to that 150 point. So it's where it's less than or equal to 6. That's when B is going to be cheaper. Total cost buying, so it's X is less than or equal to 6 is what I'm going with, not 7.3. I don't think. I might come back and flag this problem. I just want to make sure I didn't do it too hastily. But that's my feeling. If the relationship between the total cost of Y, let's clear this. Oops. If the relationship between the total cost Y of it's not working. Of Y of buying the materials and renting the tools of store C and the number of days X. Between total cost of buying the materials and renting the tools of store C and the number of days X for which the tools are rented is graphed in the XY plane. What does the slope of the line represent? Okay. So we're talking about C, and Y is the total cost, and then 90x is the slope plus 700. So the cost is the slope is how much incremental cost you have per day, which is kind of what they have over here. Oh, they even give us this. See, I didn't see this. It's the total daily rent of the cost of the tools. Yeah, it's not the total cost of the materials or the project. It's the slope is just this 90. This is how much we're paying per day. Total daily. Okay, let's move on. These are tough questions. So now we're already at 18. So we're almost halfway. And we got 40 minutes left. Jim has identical drinking glasses, each in the shape of a right circular cylinder with internal diameter of 3. So this is 3. In the internal, but that's okay. If the height of milk in each glass is about 6, okay, let's say it's here and here, and we say this is 6 and 6. What is the largest number of full milk glasses that he can pour from 1 gallon of milk? 231 cubic inches in a gallon. So let's see. What's the largest number of full milk glasses? And why did it say identical? Oh, so he's more than 2. He is infinite or something. So we've got, what is the volume of this? So volume of this is pi r squared. So it's 1.5 pi r squared. And then it's times 6. The height, that gives us the volume of a cylinder. So let's see. Pi times 1.5 squared, right, times 6 equals, make sure I did that right. And that's the number of cubic inches, so 42.4. And we want to know, and then we want to say 231 divided by that is this. So it's about 5 glasses. How many full glasses? So it's more than 5, but we want to know the amount of full glasses you can get is 5. Okay. If 3p minus 2, blah, 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 what is the least possible value of that? Well, let's look at this. So I'm just going to go ahead and solve this, to be honest, because, well, actually we can do it like this. 3p minus 2 is greater than or equal to 1. I'm going to add 4 to both sides, because I want to get 3p plus 2 on this side. So this is 3p plus 2 on this side is greater than or equal to 5. So the least value is 5. Probably faster. Okay, let's look at this guy here. We've got the mass of living organisms in a lake is defined to be the biomass of the lake. If the biomass in a lake doubles each year, which of the following graphs could model the lake? So it's doubling. That's exponential. So don't be fooled. It's not linear. It's got to be like this. So this is what may trick you. It's this guy. We're starting somewhere. We're not even starting at 0, right? So that's also another problem with that. So we're going with C. Okay. Now we're more than halfway done. In a scatter plot of this data where renewable energy consumption in the year 2000 is plotted along the x-axis, so renewable energy types, or sorry, consumptions, and renewable energy consumption in the year 2010 is plotted along the y-axis for each of the given energy sources. How many data points would be above the line y equals x? In a scatter plot, they're saying in a scatter plot, so they're not giving us the scatter plot. I got it. Oh, wow. So they want to compare 2000 to 2010, so they'd be like this. Let's see. This is a crazy question. I've never seen this. So 2000 is on x, 2010 is on y. And you notice that what's happening here is it looks like 2000 is always smaller. So if this is 1 and this is 1, it's like if this is 1, right, 2010 is lower, so the equivalent value is here. If we had 2, I'm just giving you a rough idea, right? In every case, 2000 is lower, so it's like we've gone up. Oh, no, not necessarily. No, it changes. Okay, so it would be like here for the second one. It'd be a little bit below. And then the third one, 2000, this one goes above. 2000 is actually higher than this guy. So 3 is, oh, you know what, I'm doing this backwards. Okay, hold on. So here 2010 is lower. So it's actually, if this is at 1, it's like this. This is at 2, it's like this. And then this guy is the opposite. And then this one is, wind is way down. So we've got 2000. So 2000 wind is like all the way here, but up here, okay? And then wood is, the X is a little bit bigger. I don't know, I'm just gonna kind of like do it like this. X is like, they're about the same, but X is here and Y would be here. Okay, let's get a rough idea. I'm wasting a lot of time on this question, but which best approximates, oh yeah, sorry. How many data points would be above the line y equals x? So above the line would be this one, and this one. And these would be below, so 3. All right, hopefully I did that right. I could have done that more quickly. But basically, let's think about it again. If above the line, 2000 is x, so we want the x value to be greater than the y value. So x value, so 1, 2, sorry, 2000, x value, how many are x value greater than the y? No, that would be below. Yeah, so above it would be where the y is greater than the x, 1, 2, and 3. So it's 3 points. Okay. Woo! All right, of the following, which best approximates the percent decrease in consumption of wood power in the United States from 2000 to 2010? Approximates the percent decrease from 2000 to 2010 in wood. So we're going from 2.25 to 2. So that's a drop in 0.25, so that's 1/9, right? And so 1 divided by 9 is, you could also do 0.25 divided by 2.25 equals 11%. All right, we got to pick up the pace because that really burned a lot of time. Next, it says, which of the following is true about the data shown for these 21 days? Tables will give the distribution of high temperature in degrees Fahrenheit for city A and city B over the same 21 days in March. Okay. So city A and city B. We've got a temperature of 80 for 3 times. So it's all the same. So we got 3. So this one's like, looks to be much higher frequency in this area and then lower here. These guys are kind of more spread out. The standard deviation of temperature in city A is larger. Wait, hold on. Standard deviation. So we're talking about standard deviation. Standard deviation is like distance from, these groups from the mean. The standard deviation. Shoot, I can't. I'm kind of blanking on exact. I haven't seen standard deviation question on this in a while. I can't remember exactly how to calculate this because it looks like it's like here we've got a cluster. And then it's like 1 standard deviation away. I'm almost going to say, I can't remember this, so I'm kind of guessing. I want to see their explanation. I'm leaning towards it's the same because I feel like here's our mean, or no, sorry. In this case, we've got our our median right here. In this case, well, we don't have a median, we kind of have two medians. So standard deviation, you square the difference of all of these from this guy. All right, I'm gonna say the standard deviation temperature in city B is larger. I'm just gonna go with that. I'm not too sure, so we'll read the explanation. Okay, in the circle to the left, segment AB is a diameter. The length of arc ADB is 8 pi. What is the length of the radius? So AB is a diameter. We know that the length of arc ADB, ADB, so this whole chunk here is 8 pi. And this is, by the way, a diameter. I didn't draw that right. So that's 8 pi. What is the length of the radius of the circle? So that means the full circle, this is the diameter, that means that's half circle. So the whole circle going all the way around is double that, is 16 pi. So we want the radius. So 2 pi r equals 16 pi, right? You see this? We divide both sides by 2 pi, and we get 8. So the radius equals 8. 25. The polynomial f and g are defined above. Which of the following is divisible by 2x plus 3? We could do a little synthetic division. No, let's factor these guys. I'm gonna. Oh wait, they're talking about some combination. So let's see. We want to know which one's divisible, and they're saying we add these guys. Or we do all this. How do we do this strategically? Let me try and factor, and I'm gonna see if this makes more sense that way. So we got 2, so I'm not sure how to exactly approach this. So I'm gonna factor out a 2x here, x squared plus 3x plus 2 on top. And then down here we'd have x, let's see, x plus 1, x plus 2. And up here we'd have the same thing, x plus 1, x plus 2. So these guys are the same, except this one, whole thing is multiplied by 2x. So what does that tell me? That tells me that if we add these guys, it becomes 2x plus. Oh, we multiply g of x times 3, and then we add them. So it's this one. You see that? Because we multiply by 3, and then when we add these guys, we'd be able to basically factor out a 2x plus 3 times everything else. That is insane. Okay. This is a pretty hard question. Let x and y be numbers such that x is between negative y and y. Which of the following must be true? Let's see. If x is in between y and negative y, it's greater than negative y. That definitely means that y is positive, because it can't be less than a negative and then greater than a like that doesn't make sense. So 3 is definitely right. So B and A are out. It's either C or D. So the question is 2 true? X is greater than 0. I don't know. We can't say that X is greater than 0. I'm going to say that this is it. Why? Do we know that absolute value is less than X? Absolute value of X. So we're assuming Y is positive, and we're assuming X. So X could be negative. Negative 2, negative 3. Yeah, I think that's right, because if the absolute value wasn't less than y, then this negative would be less than that negative. So I'm going to go with 1 and 3. All right, question 27 out of 38. The scatter plot to the left shows the relative housing costs and population density for several large U.S. cities in the year 2005. All right. Housing costs and population density. The line of best fit is also shown, has the equation of blah, 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 which is the following. Best explains how 61 in the equation relates. 61 is your starting point, basically, right? So at time 0, do they say this is based on time? Let me see. No, wait, maybe it's not. Oh, no, it's population density. So at 0 population density, we're starting with housing cost of 61. So 61 housing cost, it doesn't go lower than that. The lowest housing cost in the United States was about $61 per month. 2005, so it's not 61%. Oh no, it is a percent. Yeah. So this is all percentage, right? Percent of national average. So it's not A. The lowest housing cost in the United States was about 61% of the highest housing cost. No, I think this says percent of national average cost. Oh, yeah, it is. And what is this, a particular city? Yeah, this is some city. This looks good, but hold on. Even cities with low population densities, housing costs were never below 61% of our national average. Even in cities with low population densities, housing costs were likely at least 61% of the average. Oh yeah, no, this should have nothing to do with 2005. I mean, sorry, like, I feel like so we're never below 61%. We're likely at least. We're at least, not never below. Oh boy, this is very particular wording. I am actually gonna shift to C or D. So we're never below, but that's like greater than or equal to, where at least 61% is greater than or equal to as well. Never below 61, but it could be 61. So I'm having trouble distinguishing between these two. Let me see. Housing costs were never below. I'm going to say never below, not likely at least. We're never below 61% of the national average, because that's really what this is it's a hard number that you can't go below, because X is not going negative. The lowest it goes to 0. So I'm going to say C, and we're going to move on because I can't spend too much time on this. This is another one that I'd like to revisit. Which of the following is an equivalent form of the function f above in which the minimum value of f appears as a constant or coefficient? Which of the following is an equivalent form in which the minimum value of f appears as a constant or coefficient? Got it. So this is we're assuming this is a parabola. We're probably talking about vertex form, and so it's going to be one of these guys. We just need to figure out which one of these is correct. So what we're going to do is I'm going to FOIL this out. I got x squared minus 4x plus 6x, which is plus 2x minus 24. And then I'm going to do vertex normal form, where I'm going to complete the square. So half of this plus squared, which is 1. So x squared plus 2x plus 1. Okay, I'm going to kind of cut this off. Minus 24. And then we got a minus 1 to balance everything out here. And then this factors to x plus 1 squared minus 25, which is D. Oops. All right, moving on. 29. We've got 10 questions left. If x is the average of m and n, and 9, m plus 9 over 2 equals x, y is the average of 2m plus 15, and z is the average of 3m plus 18. What is the average of x plus y plus z in terms of m? So now we've got in terms of m, so we can add all these. Oh man. All right. So I'm just going to add, look, they're all over 2, so I'm going to add them all up. So it's m plus 2m plus 3m is 6m. 9 plus 15 is 24. 34 plus 8 is 42. You can use your calculator, of course, 42. So all these guys are added, right? So that becomes 3m plus 21. But this is like 3 terms now added up, so we got to divide everything by 3, so it becomes m plus 7. Crazy. The function x cubed minus x squared minus x minus whatever is graphed in the xy plane to the left. If k is a constant such that the equation fx equals k has 3 real solutions, if k is a constant such that 3 real solutions, which of the following could be the value of k? Oh, I see. So we're trying to get, there's 3 ways that we can get to this k value. Let's see here. So it's like here, here, and here. It's any point where we can see 3 different ways to get to the same x value. So it looks like it's -3 is what it would have to be. -2 wouldn't work, because there's only one solution at -2. 0 wouldn't work, definitely only 1. 2, only 1. It's got to be -3. Okay. A partially filled pool contains 600 gallons of water. A hose is turned on and water flows into the pool. So now it's going to get easier because we're going back to a new type of problem. So 600 This turnaround flows in the pool at 8 gallons per minute. Okay, that's not the right abbreviation, but how many gallons of water will be in the pool after 70 minutes? So 70 times 8 would give you 560, plus that 600 is 1160. Okay. I did it fast, but I think that's right. 8 gallons per minute times 70 minutes, blah, blah, blah. All right. The normal systolic blood pressure, P for adult males, can be modeled by the equation P equals X plus 220 over 2. Every increase of 1 year in age, how many millimeters of mercury, so X is age, how many millimeters of mercury will the normal systolic blood pressure for an adult male increase? So if this goes up by 1, all right, it becomes plus 2. We can break, you know what, this is easier if we break out like this. This becomes X over 2 plus 220 over 2, right? I'm just splitting this up, which is 110. So every time this increases by 1, right, it goes up by a half. When X is 1, it's 1/2. When X is 2, you're going up by 1. So this is the change. So we can say 1/2 or 0.5. I'm going to say 0.5. The PES Roman measurement of length is approximately 11.65 inches. So we'll do a ratio 1 PES. Okay. It is also equivalent to 16 smaller called digits. It's also equal to 16 digits. Based on these relationships, 75 Roman digits is equivalent to how many feet to the nearest 100? So 75. So let's set up a ratio. 16 over 11.65 equals 75 over X. Now this is in inches, so we're going to have to convert to feet eventually. So let's cross multiply, right? We got 16X equals 11.65 times 75. 11.65 times 75 equals 873.75. We're going to divide both sides by 16. Divide by 16. And we get 54 inches. To the nearest 100, that says. So 54.61. 54.61. Actually, wait. No, we need in feet. So then we got to divide this by 12. Let's not even round yet. Don't round. So then divide this by 12. 4.55. 4.55. Let's do a gut check. Let's make sure that makes sense. So we're saying it's about a foot, right? So 16 digits is about a foot. 16 times 5 is 80. So should be a little under 5 feet. This just makes sense. Okay, it's a gut check. In a study of bat migration, 240 male bats and 160 female have been tagged. Okay, if 100 more female bats are tagged, 100 more female bats are tagged, then we got 260. How many more male bats must be tagged so that 3/5 of the total number of bats in the study are male? So that 3/5. So we got 3/5 equals. So right now it's 500. So it's 500 plus X. How many more need to be tagged? And then 240 plus X. You see that? So the male's being added on, but it's also being added on to the final. So we can cross multiply now. So it's 1500 plus 3X, right? Cross this way. And then this guy, 5 is 1,000, 200, 1,200 plus 5X. Subtract 3X from both sides and subtract 1,200 from both sides equals 300. X equals 150. And that probably makes sense. We can do a gut check as well. But 150 gives us 390 out of 150 plus 500 is 650. So it's 39 out of 65. Divide both by 13, and that's 3/5. All right, 4 problems left with 18 minutes. It might seem like a lot, but we never know how hard these are. The dynamic pressure Q generated by fluid moving with velocity V. So this is dynamic pressure using the formula above. An aeronautical engineer uses the formula to find dynamic pressure of a fluid with a velocity of V and the same fluid moving with 1.5 V. What is the ratio of the dynamic pressure of the faster fluid to the pressure of the slower fluid. What is the ratio of the okay, so all that's happening is that V value in one, we're having an additional 1.5 squared, and the other one is just like 1 squared. What's 1.5 squared? It's actually, you can use your calculator, it's 2.25. And the other one just stays. So it's 2.25 to 1. So say the dynamic pressure of the faster to the slower, so there's more pressure. So we say 2, if they said the other way around, it'd be 1 over 2.25 or something. So this is just 2.25 over 1, which we could simplify. If we want to write it as a ratio, we could say 9 to 4. I wonder if it'll allow us to do that and give us the right answer. I'll try it, because it does say ratio. So, it does say a proper fraction. Oh yeah. So I don't think it would allow us to do a decimal. 9/4. Okay. And how did I get 9/4? I was like 2.25 over 1, and I wanted a whole number, so I'm like 4 and 4. Multiply top and bottom. I could recognize that this would make it into a whole number. The circle has length arc. Let me do this really quickly. AB. Oh yeah, and the circle to the left, circle O, and radius 10. AB, if the length of arc AB is between 5 and 6, so radius 10. Radius is 10. And then AB, it's between, and then this length here is between 5 and 6, right? 5 to 6. I think that's what it says. And what is one possible value for x, which is the angle? I think we have to use maybe trig, I don't know. And so the whole thing of this would be pi r squared, which is r is 100, so it's 100 pi is the whole thing. And this is between 5 or 6, right? So let's say 5.5, and so it just wants one possible, so 5.5. So it's like this. Sorry, let's set up the whole equation. Sorry, it's x over 360 times 100 pi, which is the whole area, equals 5.5. This will get us the equation, because now we're doing arc length of a sector, and that's how we do it. We take the percentage of this angle over 360 times the full, excuse me, I did area, I should have done circumference. It's not 100 pi, it's 2 pi r, which is 20 pi. Okay, and now we can solve this. So I'm going to, let's see, I'll divide both sides by 20 pi. That takes care of that. So 5.5 5 divided by 20 pi. You know what? Let me add parentheses just to be safe. 20 pi. And then we're going to multiply both sides by 360 times 360 equals 31.5. Oh, it wants an integer value. I just got to make sure it doesn't go too high. So I think 31 or 32 would be okay. We did right down the middle. I'm going to go with 32, and then let's test it. So 32 over 360 times 20 pi. 32 over 360 times 20 pi. And that's for between 5 and 6, so that works. 32 is a good value. Okay. So you got to be careful with the rounding. You got to make sure to test it out. You never know if that's actually the right value in a case like that. That's why I tested it. 14 minutes for 2 questions. We're in great shape. The stock price of one share in a certain company is worth 360. A stock analyst believes that the stock will lose 28% of its value each week. So basically, it's dropping down to 72% of its original value each week for the next 3 weeks. The analyst uses this equation, so 360 RT, to model the value after 2 weeks. That R is not 28%. That R is going to be what remains, which is 0.72, by the way. Okay, so it's very important, because if you do it the other way, it gets small very quickly. It's not right. So what should the value of R be? It should be 0.72, as I just stated. The nearest dollar, what does the analyst believe the value of the stock will be at the end of 3 weeks? Okay, well, let's just plug it in. I mean, I could probably calculate without a calculator, but it's 360 times 0.72, and t is the number of weeks, right? So after 3 weeks. So this is your equation. Okay, so we got 0.72. I'm doing a little out of order, but it doesn't matter. To the third power, right? Times 360 equals this. So 134.37. So let's say to the nearest dollar. So 134. Okay. All right, so we've entered everything. Let's just make sure that's saved here. Yeah, it did. So we've entered everything. We got like 12 minutes left, so quite a lot of time. I guess I'm going to review some of these. So let's see, which you definitely should do. I don't always, but you know, when I'm trying to show these. But there were a couple of these that were kind of tough, so I want to go back and make sure I gave it a good shot. This one I'm good. This one I felt really good about. This one I felt really good. This is the... Oh yeah, this one was a little crazy, so let's read this again. Shows the relative housing cost and the population density for several large U.S. cities. Oh, I thought it said one. For a U.S. city is defined by average. The relative housing cost for a U.S. city is defined by average housing cost for the city. Oh, I didn't read this. So this is already taking a division. This is the average housing over the national average. So this is the percentage. Okay, so no, I think I got that. So that's your percentage. It's basically we're seeing, is it more cheaper if it's under 100%? Is it greater than when it's over 100, like up here? So it looks like as the population density gets higher, the cost goes way above the national average, right? Because now all of a sudden it's getting higher and higher and higher and so on. And so now we want to know the 61. That 61 is the percentage of, it's like what they're saying, but it's a line of best fit. So we gotta look. That's what it is. Housing costs were never below 61% of the national average. That's wrong. It's this. In cities with low population densities, housing costs were likely at least 61% of the national average. Because this is a line of best fit. So I'm changing my answer now. I get it. It's not an actual data point. This isn't exhaustive, right? And this is just a smattering of cities that they have looked at. So I'm changing my answer to this. This is definitely not right. Lowest hot, nope, that's definitely not right. Okay, I feel better now about that question. This one I feel pretty good. We're kind of assuming that y is positive, x could be negative or positive. So let's just give an example here. We've got, let's just pretend y is 3. So 3, negative 3, and x is in between those. So if this is true, x could be 2, right? And then the absolute value of x, which is 2, is less than y. That's correct. And now let's pretend x is negative 2. Absolute value of x would still be 2. Has to be less than... Yeah, it makes sense. It makes sense. So I'm going to go stick with that. This one I felt really good about. Yeah, this one was good too. It's 8 pi, right? So that's half of 2 pi. That's basically pi r is 8 pi. So r is just straight up 8. This one. So this one is a kind of a guess. The standard deviation of temperatures in city B is larger. Like, I'm trying to remember standard deviation, like, because I just don't do it a lot. There's a, you know, the standard deviations measure how far you are from that middle value, from your measures of central tendency, and it's like the spread. So I'm saying, like, it looks like city B, they're more spread out. Right here, they're more concentrated around 79. So I'm feeling like city B has a greater standard deviation away from whatever you consider. If you want to consider this well, this would be your mode, you know, whatever. We're looking like, I'm feeling like that standard deviation is definitely bigger. This one, I think I got to the bottom of this. All right, I'll tell you what, I'm gonna just roll with it. We got 8 minutes left, but let's see how this panned out. Alrighty, it's calculating. It is calculating. Alright. Congratulations. Let's see. Alright, you know, I got 1,000 because I didn't do the reading and writing section, right? Let's see what... Oh, that means I got everything right. So 800 is perfect score, I think. Yeah, so I got them all right. So let's see. I want to read their explanation for the standard deviation. Maybe there were some other ones. Okay, so let's go to that guy. No, felt good about that. Good about that. Yes. Here we go. Okay, the standard deviation is a measure of how far the data set's values are from the mean. In the data set for city A, the large majority of data are in 3 of the 5 possible values, whereas 3 values closest to the mean. In the data set for city B, the data are more spread out with many values at the minimum and maximum. Therefore, by observation, the data for city B have a larger standard deviation. And then they talk about calculating. So yeah, this is, I couldn't remember the exact calculation, but you don't even need to in this case. I think the point is you can sort of observe and figure it out. So that's basically it for today's live stream. I hope you guys enjoyed it. I hope you guys found it helpful. I know I'm working with a few students who are taking their SATs in August, this coming August. So if you are, I'm hoping you're following along, and I'm hoping that these are of value to you. And if you have any questions, I'm getting some great questions from students on my YouTube videos as far as things they want to see. I know one student in particular mentioned they wanted to see me solve practice test 7. I'd like to go in order, but I'm trying to, and I'm entertaining that idea of maybe next week jumping ahead to practice test 7. So let me think about it a little bit more, and then of course I can come back to 5 and 6 later. Thank you guys so much for joining. Please like this video if you found it helpful. That would help me out and my channel out tremendously. And also subscribe if you want more test prep, math goodies, stuff like that. And of course, math music videos. I just dropped a new one on Monday called Compound Interest, and I'm rapping, believe it or not. So it's my first time ever rapping, and it was super fun. I hope you guys like it. Thank you guys so much for joining, and have a great day and a great rest of your week. Take it easy.